This video is for the GCSE Motion topic, Lesson 5, an equation of motion. By the end of the lesson, you should be able to apply the equation v squared minus u squared equals 2as to numerical problems. Okay, so straight into your notes then. Title is the title of the equation we're going to look at. And it says the motion of a body undergoing uniform acceleration can be described by the formula v squared minus u squared equals 2as. This term uniform acceleration means that the acceleration in our problem does not change, it remains the same. So for example, if a body's falling, the acceleration will remain 9.8 meters per second squared. The terminology, of course, is the usual symbols that we use. V is the final velocity in meters per second, u is the initial velocity in meters per second, a is the acceleration meters per second squared, and s is the distance travelled in meters. A rather nasty little looking triangle here for you to swap that round if necessary. What my advice to you would be actually to put numbers into this and then attempt to swap it around once you've actually got some real figures into your problems. You could swap this round and then get the three different versions that you could use here. So you could learn those if you wanted to, but my advice really is to use the equation that's given to you and put the numbers in. And please remember, you do not have to remember that formula, it will be given to you. Can you make that note on the slide now, please? Okay, I'm going to run through an example question with you. So again, could you put that as title in your notes? A car starts from rest and accelerates at a rate of 7 meters per second squared. After 20 meters, how fast will the car be travelling? Well, the first thing we do with these problems, I always encourage you to write down what you know first off. And the very first thing we come across is the initial velocity or starting velocity. If something starts from rest, it means its initial velocity is 0. So watch out for that in questions. They expect you to understand that. The acceleration is given to us as 7 meters per second squared. The distance travelled is 20 meters, and we've got to find out the final velocity of the car. What speed is it travelling at after it's been going 20 meters? Okay, well, write down our formula. This is what I mean by putting in the numbers. Okay, so if you put in the numbers now, you can see that that simply becomes v squared, and we can work that little lot out to be 280. And then, of course, v is the square root of that, which is 16.7 meters per second. Please make sure you've got a copy of that in your notes. Okay, you don't have to copy this slide out, but it would be useful to have a record of the questions. So if you could print off the question sheet, that would be to your advantage. Okay, 3 questions broken down into different parts. I want to point out to you first off that in questions 1 and 2, Part A require you not to use the v squared minus u squared equals 2as equation, but requires to use this first, this calculation of acceleration, which we did a couple of lessons ago. So for example here, the acceleration of the car, you're going to use change in velocity divided by time taken. You can work out the change quite easily. There's the time taken, so you can work out the deceleration of the car quite easily. Okay, so just be aware of that. Parts A in 1 and 2, you have to use that first off. Okay, pause the video, have a go at those questions. Right, the solutions then. As ever with these questions with a lot of information, it's always a good idea to write down what you know. So first question, we've got that t equals 3.6, initial velocity is 25 meters per second, final velocity is 13 meters per second. And in part A, we have to work out the acceleration, which is actually a deceleration, so it would be a negative acceleration we get, and the distance s that we've travelled. Okay, so if we use that equation for the first part, we get an acceleration of minus 3.3 meters per second squared. And if you then use that and the other bits of information into our equation of motion here, you get 69.1 meters. Question 2, the acceleration is 9.8 meters per second squared. Again, it's one of those things that you're expected to be aware of. If something's being dropped, it's the force of gravity that accelerates it, so we always use 9.8 meters per second squared. So if you use that value for acceleration and you appreciate that it's because it's dropped, its initial velocity is 0, then you can actually work out the final velocity, the velocity just before impact. So there's our information. That's what we've got to find out for part A, and part B we've got to find out the distance travelled. So if you pop in your numbers into that equation at the top there for acceleration to work out the final velocity v, you should end up with 20.6 meters per second. The distance travelled by the stone, you're then going to use a version of this equation here, the equation of motion, and you should end up with 21.6 meters. Question 3 has many parts, so write down your information. And in part A, you're expected to work out the time. Part B, the initial speed or velocity, u, and then s, a maximum height, will be the distance s travelled. Part D, as we'll see in a moment, you don't actually have to perform a calculation on, but we'll come to that in a moment. Okay, so part A, you should have got 1.8 seconds. Part B, 17.5 meters per second. Part C, 15.9 meters. And it says the speed of the ball just before it's caught by the cricketer. Well, the problem is symmetrical. The speed at which it's launched at should be the same at the speed at which it actually comes back down at, provided you've got no energy losses along the way. So the speed at which it's caught by the cricketer will be the same as the launch speed, 17.5 meters per second. If you're not happy with any of the solutions that I've given you, please contact me via Show My Homework. Okay, so that's it for today. The only thing that you need to be able to do from today's lesson is to be able to apply that particular equation. The key is to identifying what these terms mean: final velocity, initial velocity, acceleration and distance, and being able to extract them from the question.